Alright, so we're looking at 4.5 probability and counting. This is the first video I'm going to do on this section. Alright, so reading out example 51. 51. A box has 24 transistors. 4 are defective. If 4 are sold, find the following. Exactly 2, probability of all, probability of none, probability of at least 1. Now, for all of these, we're going to follow a hypergeometric format. In other words, we are going to choose the right probability. So, this is a classic probability, so on the bottom we have to have our totals. So there's 24 total transistors, and you're picking or choosing exactly 4 of them. So it's 24, choose 4 on the bottom for the total. Now, anytime we're doing a hypergeometric, we are splitting our group into 2 possibilities, and for some advanced problems, 3 or 4 different counts. But on this one, we have the 4 bad transistors and the 20 good transistors. Now, if exactly 2 of them are defective, then I'm picking 2 that are defective and 2 that are not defective. See how that works out? The bottom is choosing 4 out of the 24 total, but then we have to choose out of the 4 bad ones and the 20 good ones 2 of each. Let's do that again, this time for all are defective. If all are defective, again, it's hypergeometric. We're going to choose. There's 24 total transistors, 4 of which we're picking. There are 4 bad ones, 20 good ones. We are now going to select, we're going to choose 4 of the bad ones because all are bad, and 0 of the good ones. So the total things that I'm choosing on top have to add up to the total I'm choosing, that's 4, and I have to split my 24 into 2 groups, 4 and 20. Now if I want none of them defective, well, again, it's choose 4 bad, 20 are good, 24 are total. I want none of the bad ones, so it's 0, so I'm 4, choose 0. I want to pick 4 good ones out of the 20, so this is how many ways you can do that. And on the bottom, it's going to be 4 out of the 24 for our total. Now, when you have at least, normally it's easier to do the complement, because at least would mean 1 is defective, or 2 is defective, or 3 is defective, or 4 is defective. So I'd have to add all those up. So it's easier when you have at least most of the time to simplify your work and do 1 minus the complement. So the complement of at least 1 is none are defective. So it's going to be 1 minus our earlier probability, but we'll do it again. So it's on top, 4 choose 0 of them times 20 choose 4 of them, and that's the total ways that I can grab 4 good ones and 0 bad ones, divided by 24 choose 4, which is the total. Alright, I have a couple of homework problems up in this style, so if you have questions on using the first type of probability for 4.5 hypergeometric, they're up.